So this is called the database state. As you can see, first section grade report is for the university database. So our goal is from the information about the university, then we'd like to design the university database, which is called the schema. Do you remember this? What is a schema? Schema is a description using database language. Okay, so we are going to study how we can represent, how we can explain such a schema for the specific database throughout the semester. That is the purpose of the database design. So database schema, and so after we design, it's like the building house. After you build a house, then the next thing is somebody use that house. Okay, bring your friend, or you can sell the house for the new residents. Just like that, we'd like to insert the data. This is an instance, so we can insert the data using database languages. So also we are going to study how to use such a database language later. So by combining database schema and such a database instances, sample data, we are going to call this the state as a database state. Our goal is create a certain database state. The reason why we call this is a database state is the database is different from our file. So you can keep those information as a file, or even you can keep this information as a screenshot like this. But that's different from the database because database is kind of alive thing. Okay? Why? So last time we talked about the characteristic of the database. So database describe their own data structure as a database. Also, database allow the multiple transaction. So it has a transaction management system and so on. So database is kind of alive thing in as the computer program. So we are going to call this database state. Then later, we are going to little bit talk about such a database state is also important in terms of database consistent. So what's the meaning of consistency? It's reliable, so we can believe. So when you access the database in Bank of America, so if you cannot believe the database, can you create the account or can you deposit? No, definitely not. Database should be reliable and it's the robust. So that is called the database consistency. So database should have such a consistency at the time this database state. Certain database state is very important. So we will use such a term of the database state. So this is our goal of this class. Then to do that, before we start, so actually we are going to use a relational database, the model. So what is a database model? Model is the group of concept, rule, to design. So think about the beginning of the last week, the beginning of the class. So I mentioned about the computer is not very complicated stuff. It starts from the 0 or 1. It's a switch on and off, or the current is if there is current, it's 1, otherwise it's a 0. However, by organizing such a data, the 0 or 1, we can present a lot of the information. So to do that, we need to provide the rule and the constraint. So by combining the bunch of rule and the constraint or standard is called the model. So there are a bunch of different models, but we are going to use relational database model, which was proposed by Dr. E.F. Code, the 1969 and 1970. Okay, at the time. So in addition, the relational database was not the only database model. There are a bunch of other database models, like for example, hierarchical database model, and network database model, and also there was the object-oriented database model. It still exists, but it's not very popular. But when people design such a database system, so have you ever heard of ANSI standard? It's the American National Standard blah blah blah. It's a standard organization. So ANSI actually determine if something new technology or the new idea, new model is coming out in the market, they should make such a standard. Otherwise, for example, think about the USB. If each the manufacturer use different adapter, different the input and output, the requirement. So Samsung can only use the Samsung product, and Apple so use only the Apple the cable and like that. So they build such a standard. ANSI actually decide what is the standard of the database system. At the time they proposed the three schema architecture. So three schema architecture. First is a schema. Schema means it's a description, but there are different level of schema description in the database. So first one is the three schema architecture is we have computer. We are going to use the server or computer eventually to store the data. Okay, just like the think about the operating system. In operating system, so you are going to use the file to store the information using file system like the NTFS, the FAT32, and the UFS, the NFS, such a file system. So this is the physical level. Okay, so database eventually, no matter what types of model you are using, eventually such an information data structure will be stored at the computer. It's a physical level. So this level is called the internal, the view of the database schema. Okay, so eventually the data will be stored at certain format of the database internally. But do you know how when I create the text file or the image file, do you understand all the structure or algorithm of the JPEG or MPEG or such a MS Word? Do you know that? Some of them are interesting, but most of the people who are using such a file type, they do not know how the images are stored and how the video are created internally, right? So such an internal schema is very difficult to understand. Eventually data will be stored at the computer internally, but we don't know. So database is the same thing, even though we have such an internal schema, internal data structure, but people cannot directly use such an internal schema. Instead, we have conceptual schema. So for example, I'd like to store the student database. Student has name, ID, address. I'd like to use the ID as a key like that. Okay? At that time, did I mention anything about the internal level or the computer stuff? No, it's just the conceptual level. Okay? So which means, so without using such a computer, we can design create the schema for the name, ID, address for student. But when we store the data inside the computer using for example, Oracle, we don't know how the data is stored. This one. So this one is called the conceptual schema. They should be separated. If there is no separation, so we should understand everything about the internal. It will be very, very complicated. However, as a computer science major, eventually you'd better understand even inside of this one. So later, second part of the semester, I'd like to briefly introduce how data is stored and how index is stored, created. So this one. But for just the normal user of the database system, we don't know. We don't have to worry about too much insight. Instead, we are going to focus on the conceptual schema. Okay. Also, another level, this is the conceptual level, so this is the internal level. So conceptual level is separated from the physical part, computer part. Only, what is more important? Domain knowledge. Okay? we need to know how student, what is a student, what is the important thing, what is the when we talk about the information or data, what is the meaningful? Even though the student has the hobby is not important in our university system like that. Domain knowledge is important. However, later when we store the data, whether this is a table, in case of a table, what is the data type, which data type is doable and better performance like that. So internal schema is in charge of such a thing when we store the data. So we have internal schema and conceptual schema. The last one is the external view. External the schema, which means that if you remind the characteristic of the database system last week, the one of the characteristic of the database is the view. Multi-view characteristic means, so in the university system, for the student information everywhere. The payroll officer has the student information, the advisor needs such a student information, and the security officer needs your information everywhere. However, if each and every department create a student the database, so what happens when you move in the new apartment? You need to inform to everywhere. It's not consistent, it's not synchronized. Instead, we'd better have the one centralized database, then it can be viewed differently. Considering what? Permission, security. So for example, security office, they don't need to access GPA, but they need to access your ID and the profile. On the other hand, your advisor department need to access what? The GPA and major, but not the social security number, like that. So it's a different view. It's a different view. External view, conceptual view, and internal view. So by combining this one, so this is called the three schema architecture. Any database system has such a different level of the schema. So external level, external view, conceptual schema, conceptual level, and the internal level. So at this time, what if we separated such a different level? They should be communicate each other. Okay, so communicate. For example, using the database languages later, when we talk about the database language SQL or the SQL, so we can use such SQL to communicate the different level. And also, what is the benefit of the different level of the schema instead of combining all together?
Isolation to protect the data?
Isolation. And more importantly, it's kind of a trend of the current programming language. It's an abstraction. Think about the object-oriented concept. What is the main purpose of the object-oriented concept? We try to improve performance of developing. How? We don't have to worry about the how the string is organized. It's an abstract. It's a different class and object. We can just use. Behind, we don't have to worry about it. It's an abstraction, a lot of abstraction that provide also security, like that. So this is the same thing. And we separate the internal level, physical level, and conceptual level. So think about when we create the student table, student information, it eventually stored at the computer system. But if this one is a full, we need to migrate this one into the new space. At that time, if we separate the different conceptual view and internal view, even though this is migrated, we don't have to worry about. We don't have to change it, the conceptual view. Student name, ID, address is still same. Even though this is moved, this is separate inside, I don't care. As long as I know name, ID, address of student, I can access the data. Right? This is the program and the system. It's a separation, independence. Okay? Same thing. the external level view, conceptual level view. Student will not be changed. But if security office ask, I need the student information, you don't have to create the new one, just create external view. Right? So this is the benefit of using such a the 3 schema architecture. So it's a program. The logical data independence means logically it's a separation. Physical data independence, physical level, this is a logical independence, and this is a physical level independence. Okay, so we can now this is the standard, right? The ANSI standard. So nowadays most of even including NoSQL database, they follow such a same thing. Then question: who is in charge of such a conceptual level schema? Who design? Who create the conceptual level schema? Database design, like you. Okay, DB designer or DB architect. And who is in charge of the internal level view?
Programmers?
Programmer? Are you going to design the internally how? It will be complicated. Who created this one? Think about this, very similar as the operating system. Who create the file system? Who create such a system file like that? Manufacturer, like the Oracle, Informix, DBit, Sybase, their vendor is in charge of that. So what we need to do is project or insert the internal view, then we don't have to worry about. The worry free how to create, then we can just design, and using the SQL language we can create the database. However, if you know how the internal view is organized, it will be really, really helpful, like the performance tuning and troubleshooting. So second half of the semester, I'd like to not all the internal view, but slightly introduce some the database, the algorithm. This is a little bit tough, but it's worthwhile. Okay? Also, what about the external view? It's a very simple. So as a part of the SQL, there is a view object. You can create a view. View is kind of virtual. It's a fake table. It's not real table, but we pretend. It's like the avatar. So like that. So we can always think about such a different level of schema. First part of semester, we definitely focus on how to design this one. Second part, we will a little bit spend the time to understand the internally how your table will be created like that. Okay. Then, so as I mentioned, so to communicate, eventually to create the database system, there are different the type of languages. So altogether it's called the SQL, Structured Query Languages. So we will learn the SQL after we complete the database design. Then the SQL consists of 2 parts. Data definition language, DDL, data manipulation language. First, we should be able to create the database. How to create something. Eventually, it will be table. The name of the terminology used in the SQL is called a table. It's like a file in file system. So create the table, create the index, create something. It is the data definition language. After you build the house, we'd like to use. So how to use? Select the data, insert the data, delete the data, update the data. CRUD operation. 4 major operation is called the data manipulation language. This language benefit is a very high level. So almost without knowing anything about the SQL, actually you can understand what's going on. It's very close to the natural language. Okay, human natural language. It's very easy. That's one of the strong benefit of using SQL. So SQL is not nowadays only for the relational database model. It can be used for many applications also. Because it's a very easy, the interface, the language. Okay. There are different ways of using such a SQL. but we will talk about the more details at the end of the second half of the semester, pretty much before or after the midterm exam. Okay. So also DBMS provide bunch of this is a major thing to create the data structure for very large data and the store the data. But in addition to that, beyond that, there are a lot of the functions, okay, provided by the database management system, loading data, bulk loading, and downloading, backup, reorganization. I will talk about what is the reorganization later, and performance monitoring, report, all such a functionality are provided. Then you can focus on database design, then create, and then you can use your data from your application. Okay. So this is an overview of the DBMS. As you can see, it's the management system software component, not database model. Database model is behind that. It's a foundation. Then based on that, we can create. I'm interested. I'd like to compete with Oracle. Then you can design such a DBMS component and focusing on the internal view, design how to create the table, what is the data structure, what kind of index you use. Then you can create the software. That is the DBMS system, like the ABC, the DBMS system. Then you can compete with the MySQL and the Oracle like that. So this is an overview of such the database software component module. We will see the query optimizer, query the processor, and concurrency control, little bit backup and recovery, and the data definition language, and programming, and so on. We can cover the most important part of the DBMS functions. Okay. I want to skip this part, but it's also important. Later, when we have time to talk about, I will introduce the different the architect. You already know some part of that. Also, in your database project, the phase 1, you need to think about what kind of the system architect you are going to use. So, for example, I'd like to use the web-based the database application, which means as a backend, you should use the database, the MySQL database on the Google Cloud. But the front end, so I'm familiar with the web application. I'd like to use the Django. I'd like to use the C#.NET environment, IIS, or I'd like to create a Java application because I'm familiar with the Java. You can directly connect the database as a backend and so on. So you need to think about the based on your preference and your skill. So you can think about the design of the intelligent software architect. So that will be discussed later. So I'm going to skip them right now. And relational database model is not the only model. It's the most popular one. There are others, like the network database model, and the hierarchical database model, and the object-oriented database model, and object-relational database model. So it's also interesting to keep track of the history of the database model also. Okay, then I would like to predict what will be the next generation of the database model. Okay, so I think that maybe next one followed by the following the relational model will be among the NoSQL database is a key value. So key value will be the next the database model, but who knows? So we may have the different one. So when I was a student 20-something years ago, object relational database may be next the representative, the DBMS, but was not true. So still, relational model is the most. So there's object-oriented database model and object-relational database model, but almost you can ignore such the database model. So because the relational database model, as we have seen, is almost the top market share, the database model, and followed by NoSQL database, like the Cassandra, the MongoDB, the NoSQL database. You heard about the MongoDB and the Cassandra and so on. So they are more flexible database models. So we do not have enough time in this semester. Instead, I I'm offering the NoSQL database, then we can talk about that more details later. Okay, that's the end of the chapter 2. Any questions so far? It's just an introduction. Now we are going to start the main part of the database design. Before we start, I'd like to overview what we're going to do in this first half of the semester. To do that, yes. It's available on Canvas, but the reason why I hand out the printed copy is I'm going to use this throughout the first half of the semester. So please bring, even there's no notice, you can bring every time. So our goal is, this is the information. I know, this is still controversial. The information, somebody said is structured data. So like we have data, then if we process like the data mining technique or machine learning, deep learning, then we try to get the more meaningful information. That is the knowledge, that is the information. But what we, when we talk about the information in this class, database, at least the database design, information is just information. It's everywhere. It's like a cloud. It's not structured. It's not organized. So even the feeling and the emotion, so everything can be information. Okay? Like for example, university. University, any information regarding to the university, like the UB is most of the classroom is very hot. It's the information. Okay? And the feeling, your first impression is the information. And the students are very handsome and nice, it's the information. Everything information. But what we want to do is create a database system using what? DBMS. Especially the relational database management system. In this class, MySQL database. Using the MySQL database, we try to create the database like this. This is our goal. So how can we create the database from such information? This database does not have all the information about the database. It doesn't make sense. It's not possible. Instead, like the student, professor, even student name, ID, address. ID will be useful like the key, like that. How can we do that? So it cannot be done at once. Okay? Instead, we are going to design the database step by step by following the step by step. First step is, it's too vague. It's like a cloud. We try to collect similar information, like the student. There's one student, another student, another student. By combining all this student, I can find some common information. And also that is those are important, meaningful information. Like for example, student is a name, ID, address. That's important. I think that this kind of approach is used in many the modeling techniques. Like think about the object-oriented, the OP concept. So how can you design the object-oriented concept? What is the main part of the OP?
Class is data protection. The class is the data.
That is the characteristic, eventually. One important characteristic of the OOP. But when we start the OOP, the most important part is we regard data as what? Object. That is a starting point. That's totally different concept from the previous, the program language, like the C or none, the object-oriented programming. So how can we define such an object? So we can identify here's one object, thing one, thing two, thing three, object, real life object. It's not computer, or it's not the memory, it's not related to any data structure. Just existing thing. 1, 2, 3, 4. By combining this, the object, I can find Here's a name, here's a name, here's a name, and ID, address, is a common thing. And also this is important. So I designed the something conceptual level. Student has name, ID, address. Then what is the next step? Using Java, you need to do the programming. How? Class. We can define the class. Class is using not human language, using computer language, we can design the student. That is a class. So class has a two part, data and method. So once we decide the variable, like the name, ID, address, we should be able to access such a data, like the get value. Okay? Delete the value like the construct, using the construct. Then what is the next thing once you design the class? Create object, finally. So there are two different types of object. One is a real life object. And finally, we need to create the object. So at that time, what is the object that you create using class? Instantiation. So you can use the new in Java, instantiation, then you can create the object. It's a memory structure. In memory, you can reserve the memory area, then create the object, then return what? Reference address. Then finally, other application program can access your object using what? Address. Actually, detail, you can use a method only. Okay? So unless that value is public or the global variable, you need to use the method. Okay? That's using that the characteristic. It can be the something hide, abstract, and a bunch of the benefit of that. Okay? Sometimes complicated. But this is the general approach. This approach is used in the many, the database data model. This is the same thing. So by collecting similar thing, we can design student thing. So this one is called entity layer. So student entity. Entity is the same thing as a thing. When I explain about the OOP. So thing 1, thing 2, thing 3, thing 4. It's a real life thing. Then by combining all these things, object, we can find common information, name, ID, address, like that. So we disregard this is an entity, like that. We will see details, so you don't have to worry about right now. How many entities? Only one thing? Only student? So there should be many things. Student, professor, and class, and then we can realize sometimes they are related. The professor teach class, student take the class, like that. So this is called conceptual modeling. Most of the design include such a conceptual level design. So same thing in the database. It's a conceptual design. So among the bunch of different conceptual modeling, we are going to use ER model. You heard about what is the ER model. Actually, the author of our textbook, the Dr. Almasari, is one of the member in the conceptual design, database design group who proposed this kind of idea first time, 30, 40 years ago. So ER modeling. ER modeling is called the data model. It's not database model yet, it's just data model, which means ER modeling can be used for even object-oriented concept. Even our real life. For example, so when you get back to your home, so after the semester, so your mom, the first time, really welcome, and the nice food and the dinner and something, but a couple of days later, your parents will be, every day please clean up and wake up early and like that. So when you organize your room, so how do you organize your room? How do you clean up your room? Nobody wants to mix the operating system and database class, the stuff, the mixture. I'd like to keep only the material for the database. I'd like to keep the material for the operating system. I'd like to keep my personal stuff here, like this. My old textbook will be separate. So grouping, how can you? You can find a similar thing. It's kind of conceptual level design. Nobody wants to mix the different thing together. It will be confusing. It's very hard to find the data. So this the ER model, data model is a conceptual level. It can be used for many applications. Okay, so this is the first step. Why? Because it's too vague information. So we can collect the similar information and the conceptual design. So first step is conceptual level design, ER model. Okay. Question: do we need any computer science skill for the conceptual modeling?
No.
Actually, no. There's no relation. It's just the knowledge. Domain knowledge is important. That is the reason. In real database design or database project, after you graduation, so probably you join the project group. Your project group sometimes hire the conceptual level designer. From where? Consulting group or CPA, accounting. Why? What is the most important part of the company system? So you build the company, the database system. What is the most important part? Money flow. So money is the most important. Finance and money, and the money in and out. That is the most important thing. Then next, HR and customer relationship like that. So who knows money flow? Accounting. So it's true, really. So you can hire the Merrill Lynch or the banking consulting group or the pay a lot because they know the money flow, then the business model, then they can design your the system. Then, however, still it's not enough to create this one database. Then we need to get close. So it's one step close to the database, but still far. Why? Because it's not related to the database system. So we need to design model that close to this one is called the database. The model. It's a data model, and this one is a database model. Using this, then we can create the student relation and the professor relation, and very similar, but it's different. So this is called the database model. I show the name of the database model: network database model, object-oriented database, relational database model, object relational database, a bunch of different database model. But among them, we are going to use relational database model, which was proposed by the Dr. E.F. Cole, 1969, 1970. Okay, so really long time ago, 50 years ago. Okay, but it's still being used. So relational data. Sometimes it's called the IDB database model, like that. Okay. Then even we need to think about what? Size. What type of data structure we are going to, because it's very close to the computer stuff. So we need to think about the data type, size, and the structure like that. So this is a database model. So specifically, we are going to use a relational database model. Finally, using this model, we can create a database. Using what? DBMS. So at that time, we can use MySQL. MySQL is the relational database management system. It's a software that follows the relational model. Okay? Using what? SQL language. Using the SQL language, we are able to create. So this is our step. So right now, we are here. So this week, we'd like to discuss more details about this, and next this, and finally, you should be able to create the database system. This is an overview. Keep in mind, this is not only for this class. Any database project follow the same step. More details and more in-depth and huge size. So some of the students complain before. I did a similar thing in my programming class. Okay? Yes, you can do. So when you have the customer table, you can create a customer table, an item table, the transaction table, then I can click, then I can connect the database. When you have a small amount of, it's kind of the practice, the pretend, the database system. Database as a backend in your program. At that time, you focus on the programming part, front end. But our main focus, as I keep mentioning, the backend. We cannot create the database including the 2,000, 3,000 the table object. Okay? But eventually, you should be able to handle such a to manage such a very large database. So definitely, we need to follow such a step. Okay, so we kind of the practice using the classroom assignment and also your project and the exercise lab. We pretend we are dealing with a very large data. Okay, keep in mind such a thing. So first step, before we start, I like this slide.
Professor, I have a question.
Yes.
I'm a little bit confused about the entity. It is similar to the class?
The entity?
Yeah, it's similar to the class.
Yes. So in object-oriented concept, we call that is the class. Okay, but here, the data structure is called the relation in terms of a relational database model. But they are actually different. So we will talk about detail. What are the difference and between the relational model and object-oriented concept?
Yeah, and for the relation, it could be considered like the objects.
No, actually
it's
not.
Different?
Actually not. So that's a good question. If we regard this as an object, this is an object-oriented database model. That's I thought many people in database community, the researcher believed. So our next generation of the DBMS will be object-oriented concept. Because think about even not only the programming language already, most of them are object-oriented concept, right? So Python, the C#, .NET, and Java, and C++ is an object-oriented model. Even computing architect following the object-oriented concept, and the embedded system object-oriented concept, and the programming, everything except database. What is the main difference? So object-oriented concept consider data as an object. How can you identify the object? Object ID. That object ID is address, reference. This one? No. There's no object ID concept, object reference concept. Instead, it's not flexible. Who is the one and what is the difference? Probably the middle of the semester we will talk about. This is not object. Okay. Up to this one is very similar. But from here, object-oriented programming use the object-oriented concept model. But this one is based on the relational model. Okay, that's a very good question. And I like this slide. This is a database design process that we are going to use, follow. But if you see that this is the cloud, right? Information. Our goal is create the database system and including application programming. This is our goal, starting from here. So first, definitely, just like the many other computer science programming project, we need to analyze such a requirement. Without requirement, without problem, we don't have to, right? Because there is a problem, so we can, like building the government database, the biological database, the university registration system, so it's a problem. Then, if you take a look at this part, left-hand side part, this is called the functional analysis and the application program design and the implementation. Have you ever seen this kind of step? This is same process as what you done in your programming class, software engineering, right? So analysis, and you can define the function, functional analysis, and the design. So in terms of the software engineering, there are different ways of to create such the design, whatever, and you can implement. So this is what you have done this one. But if you take a look at this part, this is the database. Actually, when you are doing the programming assignment, programming project, you already use the data. Data is what? Sometimes memory-based, as I mentioned the last time. Memory-based, or sometimes a file, sometimes the file system, you already. That's a part of this. But when we have a very large data, so memory is not enough, file is not enough, okay? It's limited. So we separate the database part, back-end part, and we have followed the same step that I mentioned: conceptual level design, logical design, and the physical design, and finally create the database. However, as you can see, it's connected, which means database design is not only based on the data itself, okay? Like I believe data name, ID, address is important. But the advisor asked me, we should be able to access the prerequisite, previous class. Then you should add such based on requirement. So programming part will affect the database design. Also, based on the database design, your programming may be changed. So it's very important when you are using the database as a backend. The programming part sometimes may affect your database design. Sometimes because of the database design, your programming interface may be changed. So that's the common thing. So keep in mind that this kind of the step in your database project. One more time, database project is a group by 2. But if you really want to do it by yourself, please let me know. Then I'm going to assign you as the single member the group. Okay? You can self the join. So if you find your project partner, why don't you join the same project group? Okay. And the phase 1 is due on the next week, Friday, and available by the weekend. Okay, the Sunday. So, throughout the semester, I'm going to use the 2 sample database. One is, I already mentioned several times, company database. Company database is not very detailed or in-depth. It's a very high level, the company database. So why don't you go to the second page? It's our company database requirement. So we need to create a database schema design based on the following requirement. So requirement is board, which means it's important. Even though you know everything about the company, I own my own company, and also I did a couple of times startup, forget about that. So the knowledge is only based on this. Even though it doesn't make sense, so we are going to follow this requirement. This is the same thing when you are doing the real project. So if your customer asks, I need this one, this one, this one, you need to follow. Then when you implement the design and implement, if you believe this is not the better performance, we can alternate. You can suggest. It's with the discussion, you can modify. But always it's kind of Bible. So your customer, the request is the first thing you need to do. So there are several bullets. So could you read the first bullet for me?
The company is organized into departments. Each department has a name, number, and employee who manage the department. To keep track of the start date of the department manager. A department may have several locations.
Okay, thank you. So you can imagine. So company first, there are several departments. Okay, not only one, but several. Each department has a manager. Okay, and we'd like to know the start date of the manager, and also one department may have several different locations. Okay, like that. This is a requirement. Then second, good.
Each department controls a number of projects. Each project has a unique name, unique number, and is located at a single location.
It's the same thing. There is a department, and also each department has a number of projects. Okay? Then each project has a unique name. Actually, nobody asks you to design, give the information about when you design the database. Nobody gives the unique name, unique ID. Unique is a very strong word. Think about it in your the daily life. Have you ever used unique word unique? So usually not. Okay, just even sometimes if you want to emphasize a single, yeah, that may be possible, but unique. Unique is eventually used for the very important role in the database because of the explicitly mentioned. This is a unique. Everybody know unique will be used for what? Search. When you search the data, if the data is unique, it's easy, right? The UDID. But the name, one time when we have a lot of students from India, I have at least 15 students saying last name Patel. And then it's not easy to identify who's who. Right? So unique is very strong. In your real project, you may not see such a unique, the word unique. Instead, you need to find what will be the unique value of key and so on. But anyway, so then the located at a single location is explicitly mentioned. It's one location per project like that. And could you read for me the third one?
We store each employee's social security number, address, salary, sex, and birthday. Each employee works for one department but may work on several projects. We keep track of numbers of hours per week that an employee currently works on each project. We also keep track of the direct supervisor of each employee.
Yeah, we have the third important thing. The company database is employee. And also employee has a blah, 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 like the social security number, so on. Also, it describe the kind of relationship with other, like the employee and department, and employee and the project, like that. And also supervisor, how supervisor is organized. It's more detailed, okay? Then the last one.
Each employee may have a number of dependents. For each dependent, we keep track of their name, sex, birth date, and relationship to the employee.
Yes. So this is our company database. I know you know the much better than this and much more information, but we are not going to consider when we design the database. But if you believe that we need to add such information, then you can ask your customer, then discuss and design. However, unfortunately, you will not see such a requirement when you join the real life project. Most of the case, it's a bunch of file and number or old system. They are not. Your customer will not mention about we are going to have the customer ID and so on. Instead, a bunch of the customer data as an Excel file, or even sometimes printed. So from the data, number, and such information, you need to clarify the requirement. This is for your first step of the database design. This is really, really nice and really well organized. It's almost a design, okay? But your first example of the database is a company database. The second thing is university database. Later we will use university database. Both of them, you are really familiar with the company and the university databases. So I'm not going to explain the details, but if it's not explicitly mentioned, it's based on common sense, but mostly based on such a requirement. So our first step is this one. So we'd like to conceptually design the database. So as I mentioned, before, what time? So 51. Please let me know if the time is up. So sometimes I forgot to finish. So for the data model or conceptual model, so we have the requirement, but we need to organize organize such the data or information using what? We are going to ER modeling. ER modeling stands for entity relationship. The model. So sometimes called the ER model. Or there are software that utilize this modeling, like the Orwin software and so on. Even. So entity. First, we need to understand what is the entity and what is the relationship. I already explained. So when I explain about the object-oriented concept, thing 1, thing 2, thing 3, thing 4, then by combining and finding the common information, I define the student object. Then eventually create a student class like that. So what is a thing? That is an entity. So entity is the really thing, existing thing. It doesn't have the really physical existing, but in your conceptual of it, so if that there exists, that is the thing. Okay? So, for example, I'd like to design the university database, specifically student information. So, I find the student entity 1, another student entity, you are entity, you are entity, you are entity. So, I have a number of entities. Okay? That is the entity. That's so simple. So, first step is find entity. So, in our example, it's already described. Instead of providing the data, it provides the description of the data. So, for example, there might be from the first bullet, there exists the department 1 information. That includes blah, 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 blah. Department 2 information, blah, 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 blah. Department 3 information. So, to find the entity, the HR department, and name, and the department number ID, and location, like New York and Dallas. Number of and more information. This is an entity, one entity. And another entity, like the IT department, and department number ID is 2 and is located in the LA. And the other information, manager and so on. And also I can find the project 1, the department, the software, the department, and number 3, and this is the Connecticut and New York, like this. So let me simplify. Yes. So I can find a number of departments. This is an entity, this is an entity, this is an entity, and entity. So from your data or requirement, you can identify such a number of entities. Definitely, there exists employee entity, like the leave. And social security number is 1111, and the other information. Another employee, okay, James, and 2222, and other information. But they are different entities. So we can group the same meaning of, actually, same of this. This is called attribute. Attribute means the thing, the value that describes this entity. So we have attribute. But this attribute is different from this one. So if you can find the common attribute, this is what? department name. And this is department number. And this is the location. Then this is the entity type. So when you are using the data type, so type means kind of structure, it's a standard. So actually when we store the data, so how many bytes do you need to store your full name? How many bytes? You can count the letter. That's a 10. And he needs the 15. And he needs the 20 bytes. Do I need to create a different byte for each student? It's a bit complicated. Instead, just a string. It's a kind of simplified, it's kind of standard. That is called the data type. So if we consider all different cases of the data and number, our programming will be really complicated. Instead, string, number. Sometimes number can be depending on the byte, digit. Can be integer, can be double, it can be long, it can be float. Because they are using totally different number. So you can classify. But number, let's say, using string and number, we can represent all different data. It's kind of standardized. That is called the data type. So looks similarly. So this attribute, first attribute represent department name. So we can name the kind of the create the data type attribute that is the department name. This is the department number. This is the location. Then by grouping, so this is called entity type. So first step is identify from entities, from number of entities. We can group similar entities. How do we know? It's a similar way of saying using attribute. Okay, using value, then we can find the entity type. So then name it. This is the department. Similarly, this is the employee entity type. Using what? Attribute. Name, e-name, and social security number. Like that. Grouping. It's not complicated. As I mentioned before, when you clean up, organize your room, you can the step group by the subject. Database, the assignments. Database, the homework. Database. All database thing will be combined. So all department are grouped by the entity type, that is the department. Like that. Then plus their attribute. Find their attribute. So like the department number, department, the ID, and the department location. However, what if this HR department has something different information like the website URL? All the other department does not have a website. So at that time, if you believe this is not the common information, you don't have to keep. Later we will talk about how to handle this one. Sometimes you want to keep this. That is different from other. But here, so we can keep the common information. Let's go back to our requirement. So first, our step is finding entity type. I know this requirement does not have any entity information. It's already group described. So what you need to do is finding entity type directly. So what kind of entity type can you find? Department. Department is an entity type of company database, right? What else?
Project employee.
Employee is the another entity type.
Project.
Project is the another entity type. Anything else? Dependent. You already realize I use capital letter. So uppercase letter already. So it's a first example. But in your project, and the most of case later is much more complicated. Even they are not described. Instead, bunch of number and the data only. Then same thing you can find. You should be able to find, identify from the entities, common thing, grouping common the entities, then decide the entity type and their attribute and so on. So the first step is finding entity type. So department, and the employee, and project, and dependent. It's not a rule, but most of such a conceptual modeling, ER modeling, use a capital letter for the name of entity type. Then, to make us easy to understand and represent, we are going to use the diagram. Okay, diagram to represent the entity type. We can use rectangular, and rectangular, and rectangular, and rectangular. Okay. Then the next step is we need to find attribute of each entity. So, for example, department, what kind of entity? Oh, by the way, question. What about the company itself? Company can be the entity or entity type or not. What about the company?
Yes.
Entity?
Yeah.
Entity? Yes, it can be entity. However, think about how many company do we have? Only one. It's a one, and if we can create the entity type, but there's no reason. It's a way so. It's a kind of a constant fixed value. So we don't have to create. Instead, we can just keep the information in your application program. When you design website, company name or application. However, think about you own a number of companies. It's a group of companies. Nowadays, many of the company, they have the children company, child company. Okay, if you have the number of company, it can be entity type. Okay, there's no general solution in database design. It's a more practical thing and the experience you can consider. So you don't have to create the company entity type. So then the last one, attribute. Department has a name and number and manager and start date and the location. Okay. You can find as many attributes as possible. So similarly, to represent entity as an attribute, we can use the over. Also, not to confuse with the other, we can connect corresponding the entity like this. Similarly, we can create the attribute for the project. Project, it has the unique name, unique number, and the location like that. So same thing. Connect. Employee is the same thing, and dependent is the same thing. Okay. Okay. So this is the first step of ER modeling. So we did the first step and second step, entity, and eventually what we need to do, find the entity type and their attribute. And using this is called diagram. So output of conceptual modeling is ER diagram. Okay. Lastly, sometimes entity type is confused. So from now on, when I'm saying the entity, that means it's the entity type. So we can interchangeably use entities and entity types. After graduation, if you join the real project, nobody uses entity type. That means it's an entity. When you are using entity, that means that it's an entity type. But we use entity. But you should be able to differentiate. What is the difference? By grouping entities, this is an entity type. So I may ask you the question in your midterm exam. So what is the entity type? What is the entity? Only for the exam, but in the real life project, it's interchangeably we use entity and entity type. And their attribute. Next class, we are going to continue the step. Okay, so that is we already did the half of the ER modeling, entity. Next thing is relationship. Okay, so we are going to complete the ER diagram next class. Okay, question? So far, it's not complicated. It's not related to computer programming. It's just a conceptual model. Okay, even middle school, high school student can follow. Non-computer science major can follow. More important thing is your interest and the domain knowledge. Okay, so by next class, so please find your partner. Then if you want to do the single member the project Viola, so let me know. Then with my approval you can start. Otherwise, so you can find your partner. I strongly suggest to find a partner from the same section, which means undergraduate and with undergraduate, and graduate with a graduate. Otherwise, it will be complicated a little bit. Any other questions? Okay, thank you, and we will see the Wednesday, Thursday.